Section 2.2 and 2.3, we're going to kind of do these together. But a conjecture is an unproven statement based on an observation. You use inductive reasoning. Inductive reasoning, when you find a pattern, then write a conjecture for the general case. So example 1, describe how to sketch the fifth figure in the pattern, then sketch the fifth figure. All right. So if we kind of look at it, figure 1, we just have one dot, square. If we look at the second one here, let's kind of look here. We can see that we have 2 in that direction, and we have 2 in this direction. Okay, with figure 3, we have 3 in this direction, and we have 3 in this direction. Yes, I noticed, and you should notice too, that the one right here is actually shared, but again, it's following the pattern. On this one here, we have 4 in this direction, and we have 4 in this direction. Again, knowing that that bottom one is shared, but what we should see is that each figure has a length and width equal to the figure number. So knowing that, you should be able to tell me that figure 5 then will have, again, my boxes don't have to be perfect. Well, they have to be a little better than that. That's not pretty good. But we can go, there's 1 box, 2 box, 3 box. So we have 5. Again, they're not perfect, but, and then I would again have the same thing here. So there's 1, 2, 3. 1, 2, 3, 4, 5. So if you notice, I do have 5 in this direction and 5 in this direction. So I have my conjecture, and it's pretty good. All right. So the second one says make and test a conjecture about the product of a negative integer and a positive integer. So to do something like this, you should just follow some steps. So step 1, find a pattern using a few groups of small numbers. Well, let's go ahead and see. So we need a negative integer and a positive integer. Remember, those are whole numbers that we can see on the number line. So for example, how about, let's say positive 1 and negative 2. That'll work. What's that become? Negative 2. Let's see. How about negative 3 and positive 7? That one will give us negative 21. Again, I'm just making ones up. How about negative 4? And how about negative 5 and positive 4? Well, it'll be negative 20. And how about another one? How about positive 8 and negative 9? And that will give us negative 72. All right, so now it wants us to make a conjecture. So my conjecture would be, we're talking about the product. So the product of a negative integer and a positive integer is, what we say, all of them, when we multiply them together, we see that it is negative. And then they say, once you make your conjecture, just do a couple more. So let's go, how about 6 and negative 7? Would expect that to be a negative. Again, plug it in, you'd get negative 42. How about, let's go negative 8 and positive 3. That'll give us negative 24, and so on and so on. So you can see that it is doing exactly what we're asking it to do. All right, and your conjecture is true. And again, remember, this is inductive reasoning because you are finding a pattern, right? Now, to show that a conjecture is true, you must show that it is true for all cases. That means everything you try, just like these ones I was doing, all right? But to show that it is false, you need just one counterexample. So you just need one counterexample. That's pretty important. So let's go ahead and look at example 3. A student makes a conjecture about absolute values. Find a counterexample to disprove the student's conjecture. So the student's conjecture is the absolute value of the sum of two numbers is equal to the sum of the two numbers. So again, to disprove this, let's just go ahead and take two numbers. So and I'm going to take, how about 3 and negative 5? Okay. We know that the sum of the two numbers is 3 plus negative 5, which is equal to negative 2. The absolute value of the sums and if we do that, we're saying to take the absolute value, so we'll have 3 plus a negative 5, all in the absolute value. Again, inside there, we'll get the absolute value of negative 2. But again, remember, the absolute value of a negative number is a positive number. So as we can see, negative 2 does not equal positive 2. Therefore, the conjecture is false. Right? In the homework, you're going to kind of drag and drop some of this stuff. All right. Now, deductive reasoning. So we just talked about inductive reasoning showing patterns. Deductive reasoning, though, uses facts, definitions, and accepted properties and laws of logic to form a logical argument. Okay, so this is different than inductive reasoning. Okay, we have two laws of logic, but the only one that we're going to concentrate on, people, is the law of syllogism. okay, which states if hypothesis P, then conclusion Q. If hypothesis Q, then conclusion R. If these statements are true, then we can kind of state that this one here will go with this one here. All right, so notice how we're doing that. Since they're both true, we can say hypothesis P, then conclusion R. Okay, that's the one that is kind of important here. All right, so if possible, on example 5 here, use the law of syllogism to write a new conditional statement that follows from the pair of true statements. Okay, so if soccer practice is canceled, then you can go to the mall after school. Okay, and then the second one is if it is raining today, then soccer practice is canceled. So note the conclusion of the second statement is the same as the hypothesis of the first statement. All right, so the hypothesis of the second statement is the same as the hypothesis of the first. So if we kind of think about it, what it's saying here is on this conclusion, the conclusion of the second statement is the same as the hypothesis. I just read that 3 times. It says order is not important to use the law of syllogism. So remember, if we can look at it, the conclusion and the hypothesis. So if we look at that, those two go together. So if we're looking at it, we can call this one P, and then we can say Q. If P, then Q. If Q, then R. All right. So look at what we're saying here. Order is not important. So we can now use what we want to do is, since we have this one being the same, these are the 2 new ones that we're going to use in our law of syllogism. So what we can say then is if it is raining today, then you can go to the mall after school. Okay, so that's all the stuff that we're going to do in section 2.2. In 2.3, we're giving you some problems on it, but you're going to find out that a lot of these we already know. We just haven't called them postulates. Remember, a postulate is something that we can assume to be true. And then we can use these later on if we need to prove theorems, which we're going to get to here probably around 2.5 or 2.6, those sections there. All right. So again, if you just think about it, look at them real quick. I'm not going to read them all because I know that you guys can read, but like the 2-point postulate, through any 2 points there exists exactly one line. So then they're kind of giving you an example there. Through the points A and B, there's exactly one L. And then the converse of that would be a line contains at least 2 points. We can see that it has 2 right there also. So this part right here goes with this one right here. So kind of look at those people. We'll probably need to start thinking about them and maybe even memorizing them, all right, as we go through. But I'm not going to waste your time doing all of that. So I believe we should be okay now.